Juvency, let's continue our topic now, dear. Juvency, can you hear me?
Sure. Yes, I can
Let's
hear you.
continue our topic now. And today we are trying to
I see.
focus on next topic is called offset list. We are trying to focus on offset list. Wait. Offset list, route map, and PBR, policy-based routing. And today we'll focus on only these two topics, offset list and route map concept in route filtering topic. Okay, Juvency,
Okay.
let's create a design. Let's create a design for offset list. In which scenario we need to use offset list concept. Let me open a slide. Wait. Now let's talk about offset list. What is offset list concept? So to implement offset list, and see, offset list we can only use in RIP and EIGRP. Juvency.
Okay.
In RIP and EIGRP, we can discuss this route filtering method. So let's create a design. Into this design, I'm using EIGRP protocol, or you can go with RIP protocol. Right. I'm creating some loopback interface on R3, 3.3.1.1, 2.1, 3.1/24, and 192.168.30.1/24. So I'm creating some loopback here.
Okay.
Let's configure IP address first. Ten dot one dot 12.1 mask, no shutdown, router EHRP 10.1.12.0 wildcard mask, no auto summary. Let's move on R2. Interface fast Ethernet 0/0. IP address 10.1.12.2 mask, no shutdown. 0/1 10.1.23.1 mask, no shutdown. Show IP interface brief. Router EIGRP 10.1.12.0 wildcard mask. Network 10.1.23.0 wildcard mask.
Mm.
No auto summary. Let's go to our last router, R3. Interface fast Ethernet 0/1. 10.1.23.2. No shutdown. And we can create some loopback interface.
Mm.
Router EIGRP 10 network 10.1.23.0 wildcard mask. We can advertise our loopback interface.
Okay.
Now 192.168.30.0 wildcard mask. So this is our IP address configuration and routing configuration. Juvency, can you hear me?
Yes.
Now let's verify on R2. Let's verify our routing table. So I'm receiving some route information. Wait. Okay, so I'm trying to verify routing table information and I'm receiving route information with from R3 3.3.network and 192
Mm.
network, right? Juvency? And
Yes.
this is the cost. This is what? FD value. If you remember, this is FD
Yeah.
value from source to destination, total cost.
Mm.
Now, what is the requirement now? What is the requirement now? I want to increase the metric, for example. I want to change the metric for these two routes only. I want to change metric for only these two routes. So can I do this with distribution list and passive interface? Is it possible? Can I do this with distribution list? I want to increase the metric, the cost of these only these two routes. Is it possible to configure with passive interface and distribution list? Do you see?
Yes, it's possible.
No, I'm talking about, see, let me clear one more time. See, I want to increase the cost of the route. In distribution list, you can allow or you can deny a specific route. That's it. This is our task in distribution list, remember?
Mm.
And
Yeah.
in passive interface, if you use passive interface in EIGRP protocol, it will remove neighbor relationship. Remember in EIGRP and OSPF, if I'm using
Uh,
this interface as a passive interface, neighbor relationship will goes down, right?
yeah. Yeah. Yeah.
If you remember
I
our
remember.
in distribution list, we can allow or deny specific rule. That's it,
Yeah.
right?
Mm. Yeah.
Now our task is different. I want to allow
Mm.
routes, no problem, but I want to change the metric of this route. I want to change metric of these two routes, cost of these only these two routes. So I cannot do this with distribution list with passive interface. We can go with
Mm.
offset list. We can go with next option, next route filtering method. This is called what? Offset list.
Mm.
What is offset list? Offset list is a way to increase the metric of routes. Clear? There is a requirement. My point is what? There is a requirement. I want to change the metric for a specific route. There is a requirement. Offset list you can only use in RIP and EIGRP protocol. In OSPF, In OSPF, you can go with route map concept. This is our next topic, route map. But in case if you want to increase the metric of the route in RIP and EIGRP protocol, you can go with offset list. Clear my point?
Yes, clear.
Yes. So now let's try to configure here. For this, what I'm
One
doing,
one question, please.
yes, sure.
That means the offset list cannot be configured on OSPF, right?
No.
Oh,
You can only
okay.
use in EIGRP and RIP
And
protocol.
okay.
Okay, so let's try to implement what is our task. Let's create a task. I want to increase the bandwidth of these two routes. This is our task. These two routes. I
Okay.
want to change I want to change the cost. So we
Cost.
can go with configuration. First, we can create access list. Why access list? To match our route. To match
Mm.
our route, I need to create access list. So I'm using a command access list 100, or you can use, no, this is standard ACL. So I access list 10 permit what? 3.3.0.0.0 wildcard mask. Then one more network we have 1.0 wildcard. Now I can go in EIGRP protocol, and there is a command. There is a command called offset list.
Offset list. Okay.
So this offset list you can use in EIGRP, you can use in RIP protocol. So I'm using a command, what? Offset list. Now question mark, you can type ACL number here. So ACL number is what? 10. Now in and on which interface you want to apply? On which interface you want to apply? For example, this is our interface.
01.
I
Yeah.
want to apply on 0/1. So you can go to 0/1. See, if you type question mark, you have two options, in and out. So
Okay.
this route is leaving from R3, right?
Yeah.
So we can
Should
use
be
here
out.
what? Out.
Out. Yeah.
Now interface offset list. What is offset list? Offset list number.
Cost from 0. Okay.
Give me 1 minute. Give me 1 minute. Uh, offset list, and yes, number I can select. Then out. Yes. Now you can change your. This is what cost. You can
Yeah.
select a cost in between these numbers. For example, default cost on R2. I'm receiving default cost for these routes 409,600 something. Now
Yeah.
I want to increase. For example, I'm looking for 65,000,
Mm.
65,000, and I want to apply on fast Ethernet 0/1. Done. Done. Let's
Okay.
verify now again here. Let's verify. Show IP route EIGRP so you can see. Okay, wait. It's taking time. Taking time. Okay, wait. Oh, yes. Now it's update. So now you can change. Now you can verify your routing table this time so you can see for these two routes, metric is
Yeah.
changed, right?
Change the.
Clear this point?
Yes, clear.
This
But
is
one question is, what will be happen on the normal network? What the usage, which is on the first metric and the second metric? The speed will be more than others one or
yes.
only
I see.
the
I cannot change the bandwidth. You will see. The point is what?
okay,
In a
okay,
network, I cannot change the bandwidth. But in
okay,
case if I want to change the metric of any specific route, so I can use offset list.
offset, okay, offset. Okay, okay, okay.
Clear? Do you see this point?
Yeah. Yes, it's clear.
Now let's talk about next scenario. What is next scenario? For example, Let me power off these devices. Power on again. And into this design, now I'm using OSPF protocol, for example. OSPF protocol. So I'm trying to advertise all the devices in OSPF area 0. Router OSPF process ID 10.1.12.0 wildcard mask. Yes. Let's go to R2. Let's go to R3. And create loopback interface. Now, Juvency, can you hear me?
Yes.
Let's verify our roots. Let's verify our roots. So next topic, we are trying to discuss route map
Mm,
concept.
mm,
Route map. Route map. And the common use of route map. Route map concept we are using in redistributing route filtering. Redistributing route filtering method. Here we can use route map, or route map you can use in policy based routing. This is our next topic. In
mm,
to configure policy based routing, again we can take a help of route map. And when you go in BGP implementation, border gateway protocol implementation, in
mm,
BGP for route filtering, for routing update, we are using route map. Okay. So route map is
yes.
a common concept. Okay. This option we can use in redistribution, route filtering, policy based routing. This is our next topic. And when we will discuss BGP protocol, we can again discuss a route map for route filtering. Clear my point?
Yes. Very clear.
So right now our focus is on redistribution route filtering. Let's go into this
Yes.
design. And what I'm doing, I'm trying to advertise these routes. Wait, I'm trying to advertise these routes, for example, in EIGRP protocol. EIGRP protocol. Let's try to redistribute. Wait, R3, OSPF protocol. I'm trying to remove this network. I'm trying to remove this network. And these two networks I'm trying to advertise in EIGRP protocol. So 3.3.0.0 wildcard mask. wildcard mask, and network 192.168.30.0 wildcard mask. No auto summary. Now let's go to OSPF protocol, and we are trying to redistribute AIGRP into OSPF. So redistribute, remember this command, redistribute
Yes.
AIGRP 10 and submit command. You can press enter, right?
Yeah.
Let's try to redistribute, no problem. So in case if I'm trying to verify my route information on R2, so yes, I'm receiving, wait, show IP route OSPF. Yes, I'm receiving route with OE2 flag. Remember OE2,
Yeah.
OSPF external route,
External
OE2.
one. Yeah.
So here we have, this is metric type. This is what? Metric type. In OSPF, we have metric type OE2 and metric type OE1, right?
Yes.
OE1. OE2 is a default metric type. This is what? Default metric type. Default metric type in OSPF. And this OE2 metric is what? Metric is 20. You can see default metric for all routes is what? 20, right?
20. Yes.
Now, in case if you want to change metric type, you can go with OE1. You can go with this metric type, OE1, and you can also change metric. Change metric here. In OE1, we can
Okay.
change our metric. Now, what is our task exactly into the scenario? What is our task? Task is I want to wait for 3.3.0.0, for 3.3.1. For these two routes, I want to use metric type OE2, but metric I'm looking for 1500. Okay.
Okay.
And for these remaining two routes, 3.3.2.0, 3.3.3. For these two routes, I'm looking for metric type OE1, OE1, and metric is what? 2000. Clear my point?
Yes.
And a REST network. What is REST network? 192.168.30.0. This is REST network. A REST network will work as a default. Default means what? OE2 and
42.
metric type 20.
Yeah.
This is our task. So to achieve this task, we can go with route map concept. We can go with route map. Let's go to
Okay.
R3 router, R3 router, and I'm trying to configure access list first. So access list 10, format, 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 3.3.0.0 wildcard mask, one more network, 3.3.1.0. Then access list 11, format, one more access list. In 11, 3.3.2.0, wildcard
Okay.
mask, one more network, 3.0. Now let's create route map. So we have two access list. And what is the command syntax for route map? Command syntax is what? Route map is a command. You can see route
Yes.
map is a command. You can type question mark. You can give a name for this route map. I'm giving CCNP. Now question mark. You can set a sequence number. For example, I'm creating route map 1. So first you can select action permit and route map 1 I'm creating. Into this route map, what I'm saying, please match address. Command syntax what? Please match IP address.
Okay.
And what it match? What it match? Please match 10. Please match 10. And when
Okay.
10 match, 10 means what? 3.3.0.0, 3.3.1.0,
Yeah.
right? So
Yes.
please match 10. And when 10 match, then set metric. Here, if you type question mark, If you type question mark here, you can see you have two options, metric and metric type.
Type.
So please change metric type. And we have two options. What? Type 1 and type 2. So please change metric type to. Okay? It's a default. It's a default. OE2 is a default, right? Metric type.
Yes,
So
yes.
no need to define. No need to define. Let's change metric on the set metric question mark. Metric, I want to give 1500 for these two.
Okay.
Exit. I'm creating one more route map, Ccnp, format, sequence number 2. Please match IP address for 11. And if 11 match, then set metric type 1, and set metric. Metric
2000.
is what? 2000. Exit. And for rest traffic, I don't know how much routes are remaining, okay? But for rest traffic, I'm creating one more route map CCNP format 3. And here I'm not configuring anything, you can see.
Okay.
Here I'm not configuring anything. This route map is for remaining routes. Exit.
Remaining, yeah.
And now again, I'm going in OSPF protocol, router OSPF process ID. And if you remember this redistribution command, remember this
Okay.
redistribution command? I'm
Yes.
trying to delete. I'm trying to delete.
Okay.
And now let's use this command again, redistribution AIGRP 10. And I'm not using submit command. If you type question mark, this time what you have?
Roadmap.
Route map. So you can select route map. And what is route map name?
Ccnp.
CCNP. Done. Oh, wait. I need to use submit. Done. Now you can verify here. You can verify this time. This time you can verify on R2. Show IP route. Show IP route. OSPF. So you can see now. You can
Yeah.
see now 3.3.0.0 and 1.0. Metric type. These two routes, metric type is what? OE2, right? And
Yes.
metric is 1500, right?
1500, yeah.
And for 3.3.2.0 and 3.0, metric type is what? OE1.
2010.
And metric is what? 2010. Why 2010? Because with each hope in OE1, with each hope, it will add 10 number. Here you define 2000. So here we have 2010. When R2 will send this
Okay.
traffic, then it's a 2020.
Okay.
You can verify. Wait.
Oh,
On R1, show IP route OSPF. So you can see here
yeah.
you have what? 2020. So now let's go to R2 again. So, and this is our default remaining traffic.
Yeah.
OE2 and metric is what?
10. 20.
Yes. Clear these two topics? Offset list and route map.
Now, yeah.
This is our topic for today. Okay.
Okay.
Now we can focus on PBR, policy-based routing. Tomorrow we can finish our PBR concept and route filtering method.
Okay.
Okay. After that, can we start BGP protocol? UNC?
Yeah. BGP. I was waiting for this.
Yes. So let's finish this topic, this redistribution tomorrow. And maybe from Wednesday, we can start BGP protocol.
Okay.
Okay, dear? I'm
Okay.
sharing this recording in 15 minutes. Bye, UNC. Take care, dear.
Thank you.
Bye. Bye.
Bye.